So in this video, which is on assignment number 2, we're going to be converting polynomials between factored form and standard form. And we're going to be finding the zeros of polynomials. We're going to be discussing briefly about how that relates to the graphs. And we're going to be finding relative minimums and relative maximum points on the graph. So a lot to talk about. Let's go ahead and get started. So let's first take a look at this. We have a polynomial here in standard form. 2x to the third minus 14x squared plus 20x, and we want to put it in factored form. So one of the first things that we could probably do is look to see if there's a common term that goes into all three of those terms. And there is. There's a 2 and an x in each of those terms. So I'm going to start by factoring out a 2x. And then 2x times x squared is 2x to the third. 2x times negative 7x is negative 14x squared. And 2x times 10 is equal to 20x. And so that's the beginning of my factoring, but then I might be able to factor it further. I have the 2x out here, but then I think I could take this quadratic trinomial and factor it even further. So to do this, I'm going to have x times x, that gives me x squared, and then I want something here and here that when I multiply it together gives me a positive 10, but when I add it together it gives me a negative 7, and that would be negative 5 and negative 2. And so this polynomial right here in factored form looks like this. 2x times x minus 5 times x minus 2. So then we're going to look to see if we can figure out what the zeros are of this function. So if, for example, normally we have this is equal to y equals this, but if we want to find out when y is equal to 0, we want to find out when is all this equal to 0. In other words, when is the y 0? And so it's just like earlier when we had two things that multiplied together to give us 0. One of them had to be 0. Now we have three things that multiply together to give us 0. One of those three things has to be 0. And so it could be that 2x is 0. It could be that x minus 5 is 0. Or it could be that x minus 2 is 0. And if 2x is 0, I could divide by 2, and one of the zeros is 0. If I add 5 to both sides in this equation, x would be 5. And if I add 2 to both sides in this equation, x is going to be 2. These three numbers are called the zeros of the polynomial, because that's when that's the x value that makes the y value equal to 0. So here's what this means as far as the graph goes. If I were to graph these things, I'm going to do this up here. If I were to graph these things, I know that the y value is 1 or 2 or 3. I know that the y value is 0 when x is 0, when x is 1, 2, 3, 4, 5, or when x is 2. So those are the 3 points where it's going to hit the x-axis. Now, I'm not exactly sure what is going to happen between those points, but I can try to figure out what's going to happen by plugging in values. Like, for example, I know, let's start with the very left. If I plug in a negative 1 and I plug it into these factors here, this is going to be a negative number. 2 times a negative 1, that's negative. I'm going to have a negative 1 and a negative 5 here. That's another negative. And then a negative 2 and a negative, or a negative and a negative 2, that's another negative. And when I multiply three negatives together, I have three negatives down here. When I multiply three negatives together, I know that it's going to be negative here. And so it's going to do something like that. Well, then I can plug in maybe the value of 1, because 1 is between 0 and 2. And if I plug in 1, let's just take a look at the signs. If I plug in 1 to the first term, or the first factor here, 2 times 1, that's positive 2. 1 minus 5, that's a negative number. 1 minus 2, that's another negative number. When I multiply positive times two negatives, I'm going to end up with a positive value. And so between these two zeros, it's going to look something like that. Then I could plug in maybe a 3 or a 4. Let's just say I plug in a 3 because that's between 2 and 5. If I plug in a 3, I'm going to have a positive 6 here. 3 minus 5, well, that's a negative number. 3 minus 2, that's a positive number. And when I multiply two positives times a negative, I know I'm going to end up with a negative, which means between this interval here, between the 2 and 5, it's got to be negative. And then when I plug in something above 5, like if I plug in a 6, I'm going to have a positive, I'm going to have another positive, and I'm going to have another positive. And 3 positives, when I multiply them together, gives me something positive. And so this polynomial is going to look something kind of like this graph here. We're going to get more into that later on. So what we want to do here in example 2 is we want to write a function in standard form given these zeros. So these are the zeros of the polynomial, which means that one of the factors, if 1 is a 0, one of the factors has to be x minus 1. If 3 is a 0, another factor has to be x minus 3. And if negative 2 is a 0, that means x minus negative 2 or x plus 2 is another factor. We're just kind of working in the other direction. The last problem, we were given the equation in standard form and we factored it into factored form and then set it equal to 0 to find the zeros. Now we're given the 3 zeros and we're going to put it in factored form first, which looks like this. And then we're going to multiply these factors together in order to write it in standard form. And so I'm going to start by multiplying these two factors together. I'm going to FOIL. X times x is x squared. X times negative 3 is negative 3x. Negative 1 times x is negative 1x. And negative 1 times negative 3 is positive 3. And that simplifies to x squared minus 4x plus 3. But then I have to take that and multiply that whole thing by x plus 2. So when I do that, I'm going to have x squared times x, which is x to the third. X squared times 2 is 2x squared. Then negative 4 times x is negative 4x squared. Negative 4 times 2 is negative 8x. And then when I multiply the 3 out, 3 times x is 3x. And 3 times 2 is 6. So when I simplify my terms, I have my x to the third. I have 2x squared minus 4x squared, which is negative 2x squared. I have a negative 8x plus 3x, which is negative 5x plus 6. And so you can see my answer there looks like that. So let's review this again. I'm going to start with a polynomial in standard form. This time it's a 6th degree polynomial. So I am going to factor out what they have in common, and it looks like the 12, the 36, and the 27, it looks like what they have in common is a 3. And I also can take out an x to the 4th. And so 3x to the 4th times 4x squared would give me 12x, this is squared, would give me 12x to the 6th. 3x to the 4th times a negative 12x. 3 times negative 12 is negative 36. X to the 4th times x is x to the 5th. And then 3 times 9 is 27x to the 4th. And so then I have the 3x to the 4th, and I am going to see if I can factor this further. So let's try 2x and 2x. If this doesn't work, I'm going to come back and try 4x and 1x. And then I want something here that multiplies together to give me 9, but it has to add up to a negative number. So I'm going to try negative 3 and negative 3. And so my middle terms, this is negative 6x here. And my outside terms, that's also negative 6x, which does give me negative 12x. And so I have some zeros here. If this is equal to 0, either 3x to the 4th is 0. And if I divided by 3 and took the 4th root of that, I know that x here has to be 0. For these are the same thing. And when I solve those for 0, I would add 3. If I set them equal to 0, I'd add 3 and divide by 2. And x would end up being positive 3 halves. And so these two things are my zeros. But let's get into the idea of multiplicity. Multiplicity means how many times does that 0 occur. So for example, when I have 3x to the 4th, I could write that as 3 times x times x times x times x. And if this is equal to 0, one of these has to be 0. Well, it could be this one's that's 0, this one's that's 0, this one is 0, or this one is 0, which means this 0 here really shows up 4 different times. That means that this has a multiplicity of 4. So the 0 is a 0, but it has a multiplicity of 4. 3 halves has a multiplicity of 2, and the reason why it has a multiplicity of 2 is because it shows up twice. this could be, if this x is 3 halves, then I have a 0. And if this x is 3 halves, I have a 0. And so, again, I could plot these 2 points on a graph. It would look something like this. I would have a point here at 0, and I would have a point at 3 halves. Here's 1, here's 2. 3 halves would be about right there. And then I could just try to plug in different points to see what the intervals look like. If I try to plug in a negative number, well, then I'm going to have a negative times a negative times a negative times a negative, 4 negatives. 1, 2, 3, 4 negatives. If I plug in a negative number here, like 2 times negative 1, that's also negative. The other one's negative. If I multiply 6 negatives together, I am going to end up with a positive number. 2 negatives make a positive. These 2 negatives make a positive. These 2 negatives make a positive. So this is going to look something like this. Then if I plug in a 1, if these 4 zeros here are all going to be positive, so I'm going to have 4 positives. If I plug in a 1 here and here, I'm going to have 2 minus 3, which means it's going to be negative. And so I have these 2 make a positive, these 2 make a positive, these 2 also make a positive. So what's going to happen here is it's going to touch at 0, but it's going to back up and come back down and hit 0 here. Then if I plug in 3, again, I'm going to have 4 positives, 1, 2, 3, 4 when I plug them in here. If I plug a 3 in here, 2 times 3 is 6 minus 3, well, that's positive. And so both of those are positive. And when I multiply 6 positives together, it is positive again. And so this graph is going to look something like that. Now, we don't know how high up it's going to go or how low it's going to go, but we know it's going to look something like that. What we're going to learn next is that this point here is called a relative maximum point. This point here is called a relative minimum point because it's a maximum point between a certain interval. This is a relative minimum point between maybe this interval here. And then if I go from here to here, I will have another relative minimum point. And so it's not an ultimate maximum point like you have in a parabola, because this would be an ultimate maximum point because there isn't anything that gets bigger than that. If I had a parabola, this would be an ultimate minimum point because there's nothing that gets lower than that. But if I have something that curves and comes back around like that, I would have a relative minimum point here and a relative maximum point here. And that's what we're going to get into next. Let's take a look at this next problem. So to make sure I have enough time to explain this, I'm going to do this problem on the next video. So if you go to the next video, you can watch how we're going to do this problem.